Whoa, that's a lot of writing on the screen. But in this video, I just want to briefly go over what I think are Deno game changers. That is, we had Node, but what does Deno really offer that is better, in my opinion, than Node? We've learned what the internal architecture of Deno is and how that's different from Node, but at the end of the day, who cares? As programmers, we just want to be productive. We want to be able to build things, and we want to build things well. How does Deno help us do that? Now, all of these topics that you see here are things that we're going to really dive deep on and learn as we go through the course. As we're building our applications, we're going to really understand them. But I want to introduce these topics to you. Some of them we've already learned, just so that you're aware. And in my opinion, Deno is still young, but because it's able to learn from past mistakes, use modern tools, it actually improves a lot on what we had before. And I think these are the things that will make it really grow and flourish in the future. The first one is something we've already talked about, this idea of first-class TypeScript support. That is, we can use TypeScript out of the box. Whether we want to take advantage of strictly typed language like TypeScript, or whether we just want to write in JavaScript. We don't need to do any setup whatsoever. If we want to use TypeScript, all we need to do is use a .ts file. If we want to just use JavaScript, a .js file. Nice and easy, unlike Node where you had to install an npm module like tsnode. Next is we have this idea of ES modules. You see, when we first got Node in 2009, JavaScript didn't really have its own module system. Node used something called CommonJS to be able to import modules. Think of modules as different files. Let's say you wanted to use a popular library like bcrypt, which allows you to hash passwords, essentially allows us to store passwords of users in a safe format. Now, if you wanted to use bcrypt, you would go to npm, you would search for bcrypt, and then you would install it using npm install. And then finally, to use it in your JavaScript file, you'd use this require syntax, which is CommonJS. Now, this isn't JavaScript. This is a non-standard way to include different pieces of code from third-party libraries. With ES6, JavaScript finally got modules. So instead of using require, we can use import, export. And it's a standard JavaScript way of doing things. And Deno allows us to do that now. Node also allows import and exports now with their latest releases, but they still have to support this CommonJS syntax. So in a Node program, we can actually do something really fun. For example, if I go to the standard library, which we'll talk about, and I go to examples, and in here we have a welcome.ts that simply console logs welcome to Deno. If I copy this URL like this, and now I import, just like we could with ES modules, I will import this URL. If I run this, Deno run deno2.js, I get welcome to Deno. So it recognizes import, but you may have noticed that I can also just use a URL. I don't need to npm install anything. For example, if I really wanted to, I can go back here to the standard examples, and I can click on a chat application that has a server.ts. So I'm going to just copy this URL and now import in here. Same thing. Save and run. Oh, I get an error. Now, why is that? This goes to the next point, permission denied. And this is because Deno has security in mind. You see, with Node, when you install a package from npm, that package can do anything. If I wrote a piece of code that said, hey, download me, and once it's downloaded, go to the user's, passwords folder, or a folder that has a bunch of secrets, copy that information, and then send it to me, well, nothing's going to stop you from doing that. Because any script that we use from online that runs on our machine has permission to do anything that the user has permission to do. So yes, when we download packages from npm, we trust that those packages are secure. But how many of us actually check these packages? We've had many issues over the years with npm packages having vulnerabilities or being manipulated in a way to try to do malicious things. Deno, on the other hand, doesn't allow that out of the box. It creates what we call a sandbox. Just like a browser, when you open up a browser, that website can't really access your file system, can't do anything outside the browser. In the same way, Deno doesn't let the program do things that it shouldn't do outside of this sandbox environment. And it's saying, hey, this program that you just downloaded from somewhere online is asking for network access to open up one of your ports. So in order for me to allow that, I have to give it the permission. So I have to say --allow -net. And we'll get into some of these security features later on in the course. But by doing this, I'm now saying, yes, I will allow this script because I trust it to open up a chat server. And I go to localhost 8080. I have a chat application. I can say, hello. I can click send and I have hello. Now, because we don't have to use npm and because we can import scripts just by using URLs, that means we don't necessarily need a centralized place to have modules. For example, npm is owned by Microsoft, and Microsoft, controls that registry of packages. People put their JavaScript code over there and people from around the world can download it. But by having this decentralized place and decentralized ways to distribute packages, sure, we'll have centralized places that will maybe collect packages, like even Deno has over here, third-party modules. I myself can host anywhere in the world, any way I want, as long as I have a URL with my script, I can share it with anybody. And that brings in a lot of neat features. Finally, Deno also has something that's very common in a lot of languages, like Python, a standard library. This is a library that the creators of Deno, that the contributors of Deno have actually approved. So although it doesn't come out of the box with Deno, it has these modules that are really, really useful, that have been tested, that have been made sure to work properly, and that are constantly updated. If we go to the Deno documentation, we see the standard library here. And these are all the things that are standard, that we can trust are good packages. For example, the FS module, which allows us to access file systems. Or the HTTP module, which allows us to create servers that we're going to be using. By having a standard library, we all can standardize on some of the often used features, like creating an HTTP server, versus in Node land, where anybody creates a bunch of packages and we have to decide which one's good, which one's not. This doesn't mean that we can't have packages or modules outside of the standard library. We have third-party modules, which again are created by the community. So for example, bcrypt over here that we talked about on npm, we have bcrypt for Deno land as well. And you see here that we can just import it like this. We don't have to require it like we did with bcrypt. We don't have to npm install anything. This video is getting a little long. We're halfway through, just a few more to go. Let's take a break and I'll see you in the next one. Now, next, another great thing about Deno is that it has built-in tooling. You see, to have a professional node setup, you would, let's say, include TypeScript, so TS Node. You would maybe include Jest as a testing library, Prettier maybe to format your code, or NodeMon to check file changes. Deno, on the other hand, has everything built in. It means that with Deno, when we installed it, it comes already with a testing library. It comes with formatting. It comes with file watchers, with bundling. So instead of having to decide what test library to install, what formatter should I install, all these things are taken care of for you. As a community, we all have a standard. Everybody just uses the same tools. And as someone that's been working with Node for a while, having that standardization and having everything built in out of the box just makes things so much nicer. It also means that when we look at code examples online, most of the code we're going to understand because everybody's using the same tools. The next one, this is a big one. It's this idea of browser compatible API. It means that a simple Hello World program in Deno is just that, a JavaScript program that can run on the browser. As a matter of fact, in Deno, unless you're using the Deno namespace that we've seen before, programs should just run on the browser without changing anything. Now, with Node, we had things like the global keyword that is, well, not part of the browser. If I used global in the developer console over here, I'll get an error. If I use the require syntax, I get an error because Node isn't really JavaScript. But with Deno, as long as I'm not using the Deno namespace, pretty much everything else is browser compatible. So if we go back to Deno and look at the runtime API, although we have things that browsers can't do, such as copy file or copy file sync, which allows us to access the file system, so work with the computer. Anything that is browser related can be done in Deno using the Windows namespace. So add event listener, set timeout, URL search params, crypto. All these things are compatible so that if I open my browser and I do window, this is the window object that the browser gives us. And the thing is, in Deno, we have this compatibility. Deno also has the window object. Now, this is great for front-end developers because, well, you can write Deno code and front-end code, and most of it is going to be compatible. Another beauty is things like fetch, which allows us to fetch resources across the web, is built into Deno. So I can use fetch in Deno, and you see over here that, yep, we definitely have fetch. In Node, fetch doesn't exist. The beauty is that by using these web standards, Deno almost makes sure that in the future it's going to work because web standards don't change. Nobody wants to break the web. So when the web decides that fetch is going to be a part of the window object, well, then it's going to be part of the window object for a long time, and that will be the standard. So Deno follows this browser compatible API to make sure that it will not break in the future. Next is the idea of a single executable. And we saw this when we downloaded Deno. If I go to Deno here that we installed in the bin folder, you see that it's a single file, a Deno executable that I can just double click. I can send this to any computer. And as long as a computer has this, it can run the Deno runtime. So that means I can run JavaScript code anywhere that has this executable. Now, having a single executable leads to some really interesting things that we'll talk about later. Last two here. asynchronous code in Deno always returns a promise. Now in Node, that's not always the case. Node was created before we really had the promise syntax in JavaScript. Although some things in Node return a promise when they're asynchronous, sometimes we have constructors like permissify that we need to wrap around. In Node, there's a lot of other things that happen. And anytime a new feature in JavaScript comes up, there's a lot of workarounds that need to be implemented. Versus in Deno, because we know it's written in Rust, all it does, anytime we use promises or any asynchronous code, the Rust backend of Deno translates to what we call a Rust future, which is a promise in Rustland. In Rust, we call promises futures. So anytime we do a promise or asynchronous action in Deno, it translates to a Rust future and it returns as a promise. This essentially makes sure that anytime we do asynchronous code, we can use promises. So we can use keywords like await in our asynchronous code. And there's a lot of other things that Deno takes advantage of with JavaScript becoming more modern, like typed arrays and many other things. As a Deno programmer though, you don't need to worry too much about it other than know that it's using the latest features in JavaScript to make sure that, unlike Node that's constantly trying to play catch up, is now using a modern version of JavaScript and cleans up the code a lot more. Now, the final thing I wanted to talk to you about is this idea of opinionated modules. If we go to the Deno documentation and we go to the manual, there's an area called the style guide here. And the style guide actually gives you suggestions of how you should style your modules. So if you're writing a module for Deno, it has certain requirements or suggestions to make sure that we as a community have a standard of how we build modules. For example, we want to have max 2 arguments in an object. We want to export the file a certain way. We want to use testing documentation. Now, you can read through this style guide yourself. By having these standard ways of creating modules, we avoid the chaos that comes with using things like NPM, where anybody, anywhere, anyhow can publish a package. So, what does the future of Deno hold? It's so much younger than Node. Is it going to surpass Node? Is it going to become what Node was in 2009 and then take over the server-side JavaScript world? Who knows? The thing is, nobody can predict the future. At the end of the day, the valuable skills are the ones that people find productive. And Deno, in my opinion, can be a really productive tool. I really like it. And I think Deno has a great future. But in order to compete with the behemoth that is Node, it has one last thing. All the features are great, but at the end of the day, it needs the community. You see, without the community, Deno is just a fun project. The reason that Node became so popular was because it now has the largest community when it comes to modules on NPM. Any tool, any script that you want, you can probably find on NPM. The way Deno succeeds is if it's able to create this community. And as long as people start building modules for Deno, start getting involved in Deno, and start working, and companies start building projects with Deno, then the underlying architecture, the features, and the way that it's designed is better than Node. So this is the last missing piece. If the community forms around Deno, there's nothing stopping Deno from being the ultimate JavaScript runtime. And for me personally, I'm heavily invested in Deno because I think this is a gamble worth taking. I'll see you in the next one. Bye-bye. I want to take a quick video to talk about this single executable feature of Deno. And we should already know this by now, right? Deno is a single executable right here. It's just one file over here, what we call an executable. On Windows, there will be a .exe file where we can double click and run Deno. Now, Deno takes the role of what we call a runtime, but also a package manager, right? It uses the standard browser compatible protocol for loading modules, which is, well, URLs. When I run something like import here, Deno acts like a package manager, right? It downloads this and then runs it for me. Or let's say here, I'm going to say console log hi. Or you know what, let's do hello. Now, if I save this, is this a single executable file? Not really, right? I have the runtime and I give this deno2.js file to the runtime to run it. And it runs it for me. But it's not one file, it's two files. It's the Deno single file executable and the deno2.js. Now, the reason I wanted to do this video is because of a potential future feature that I think could be the killer feature for Deno. And if you go to the Deno repository, it's one of the most liked and loved features that I hope in the future we're going to see. Now, if you read this comment, let's see if we understand this. Is there any way to support compiling Deno scripts into a single executable? This person saw single executable as a feature, but the code that follows seems to suggest it's Deno as the single executable, not the programs executed with it. So a language like Go actually has this. So if you run go build main.go, it actually creates a single executable file. And Deno is currently working on this feature. It's currently on the long-term roadmap. But what this means and why this is so exciting, I will be able to write programs like this, obviously more complicated than this, and then combine it into the Deno runtime into a single file. Imagine this deno2.js and the Deno executable combined into one executable, and this can now be moved anywhere in the world to any computer. What this means is that you can run a program without any external dependencies. That means I can run a program without installing anything. I can make sure that this program runs on any computer in the world because it has what we call no dependencies. It's not dependent on anything. Unlike Node that has the Node modules folder that has a ton of packages that need to be installed in order to work, we can potentially have a single executable of our programs, a simple drag and drop that we can move to anywhere in the world. And if you're new to programming, this doesn't seem like a big deal, but trust me, one of the biggest pains that you have as a programmer is getting your code to run on a different machine. Millions of dollars have been spent trying to solve this issue. And if Deno is able to do this, this is going to be a killer feature. Let's talk about security. Now we know that Deno comes with some really nice security features, such as permissions when we try to run a program and it needs access outside of the regular program, maybe environment, maybe file permission, maybe network permission. It's going to give us an error and say, hey, are you sure you want to allow this program access? This is what we call a sandbox. We want an area, as if you're having a child, they're allowed to play with sand within this container, but they can't go around the house and spread sand everywhere and destroy your house. In the same manner, most programs have this idea of sandboxes. when it comes to security practices and programming, the general rule is to not trust anybody. If you're not writing your own code, if you're accepting user permission, user input, if you're using third-party modules, you shouldn't trust anybody. You shouldn't just assume that people have good intentions or that users send you the correct information. So we have this sandbox environment to make sure that people don't have access to places that they shouldn't have access to. Most security vulnerabilities are exactly that. People getting access to a location on a computer that they shouldn't have access to. This idea of security is everywhere in computer programming. For example, initially we had things like virtual machines or VMs where we could deploy our apps, and there would be a little computer inside another computer that had its own operating system, its own memory, so that you were contained in that sandbox. Then we got things like containers and Docker, where now we can deploy containers and we can set within those containers permissions of what access and permissions we allow into the container and out of the container. But this is something we see every day as well. For example, your browser is sandboxed. When we run a website, that website only has permissions within your tab. It can't really go outside of your browser tab and access memory or information from anywhere else. Same with your iPhone, for example. When you want to take a picture on an app, it will usually ask you for permission. Hey, can I access your camera? Hey, can I access your photos? All over computing, we have this idea of sandbox. But all of these are things that run programs. But even inside of them, using Deno, even before we deploy to these areas, we can have our own code sandbox. And that's what Deno does. Yes, we can have security measure in place in a container. But even before that, by adding security layer to Deno, we can be extra sure, especially when we use code that we didn't write. For example, on a Node.js app, there's nothing stopping somebody from stealing, let's say, your secrets from your computer, such as an SSH key. For example, you download ESLint, a popular Node package. You download it, but somebody had just modified it. And that modified ESLint package is going to access your file where your SSH keys are stored and then steal it and sending it to the attacker's server. So this is why we usually install Node packages from people that we trust. But we can never be certain of projects. Code can be modified. Projects can become stale. Projects can be hacked. Instead of just trusting, we can make sure that if we're ever running a program with Deno, that we give it the right permission. For example, if we never need a program to access files, then why should we give it access to that file? As Ryan Dahl said, your linter shouldn't get complete access to your computer and network. You should only give it access to what it needs. At the end of the day, it goes back to this philosophy that Deno is kind of like a browser. Just like a browser doesn't give you permission to do things, Deno doesn't give you permission unless you specifically allow it. Now, we'll explore this idea of security even more, but I want to point out at an interesting thing that we can now do. Because with permissions, we can give environment access, network access, file system access, even running things like sub-processes. How do we know what permissions Deno allows us to have? Well, let's go check out the code. We go to the Deno repository and let's think. Well, the permission errors are getting in our CLI or command line interface. That's where we get the error. So let's check out that folder. And if we go here, let's go to let's see if we see the permissions. All right, we see the permission over here for Rust. So that is in .rs, so that is Rust. And there should be one permission for TypeScript as well. Let's see. Let's go to JS. There you go, permissions TS. Remember that Deno has a TypeScript or JavaScript side and a Rust side. So if we go to permissions here, we see that, oh, there you go. Export type, permission name, and these are all the permissions that we have. Look at that. And it also says, hey, keep these in sync with the CLI permission in the Rust side of the code. So again, if we go back to the Rust side of the code, where was it? Permissions.rs. There we go. These are our permissions. In Rust, if I scroll through, there you go. We have some Deno permissions in here as well. I think it's important to be able to understand the code of the runtime and be able to explore it like I just shown you. The last thing I want to leave you with is an idea that this security model in Rust allows. We can envision a future where we now have all these mini microservices, mini servers, mini scripts that we write in Deno. Each one has its own Deno executable, that is its own Deno runtime, and each one has certain permissions that it has. Maybe this one has permission to write to files. Maybe this one has permissions to read the environment or plugins. We can fine-grain control of each server so that instead of giving access to everything, each server or each script has its own permission. And we can build a microservice architecture with security in mind, where each piece of software only has access to what it needs. And if it ever uses third-party modules or code that other people have written, they only have access to this piece over here instead of the whole system. This is more of a big picture concept, but it shows the importance of having this fine-grained security feature that Deno allows. I'll see you in the next one. Bye-bye.
Hello! Okay, you might have noticed that each time you try to run your application, you need to explicitly enable all of the permissions that it uses. You might soon grow tired of this and ask, is there a better way? Let's build a simple Deno program to output our environmental variables and look at what we can do to make managing the required permissions a little bit easier. Let's start by creating a file, main.ts, and we're just going to log a hello message. So we're going to use console.log and say hello. The only thing is, we're not happy with just an arbitrary hello. We want this to be customized based on who you are. Remember that path variable when we were installing Deno? There's another variable called user on macOS and Linux and username on Windows that we can use to get the current user's name. So in my Windows PowerShell, I can do echo env username, and it's going to tell me my name is Adam. In command prompt, this would look like echo user name. And in Bash, on macOS or Linux, we can do echo user. All right, so back in Deno, we can use this built-in deno.env object, which we can see here has a get, a set, and a toObject function. And we're going to use this .get, which we can see retrieves the value of an environmental variable to get our user variable. And again, on Windows, this would be user name. Okay, so what happens when we try to run this program? Well, we'll do Deno run, and then the name of our file, so main.ts. And Deno tells us, error, uncaught permission denied. We need access to the environmental variables with this allow env flag. It makes sense for Deno to be asking us for permission because sometimes the things that we keep in the environment can be things like application secrets or passwords even. So it makes sense for a program to ask for permission to access those environmental variables before it can do so. Okay, so let's pass in this allow env flag, --allow -env. And all right, Deno is telling us hello. But what happens when we get tired of typing these permissions out every time we want to run our application? Well, we have some alternatives. We can do Deno run --allow -all, and that'll work as well. Or we can do the short form of this, which is -a. The thing is, this will enable all permissions on this one program. This is not recommended because it removes one of the key security advantages that having specific permissions gives us. One of Deno's big advantages over other runtimes is its security. Two key security principles that Deno is following here are the principle of least privilege and whitelisting. Let's see what they mean. The United States Cybersecurity and Infrastructure Security Agency, with this very serious sounding name, tells us the principle of least privilege states that a subject should be given only those privileges needed for it to complete its task. Makes sense, right? We don't need to grant our little Deno program permission to make network requests because it's not making any. It only needs access to that one environmental variable. The other principle, whitelisting, is the practice of explicitly allowing some entities access to a particular privilege. And importantly, it is the reverse of blacklisting. Instead of saying what we're not allowed to do, we say what we are allowed to do. Have you ever tried to tell someone, maybe a young child, what they can't do? They'll always find a way around it. It's much more specific to say what is allowed. That way, you're less likely to miss one of the rules that you want to enforce. So going back to our program, when we're allowing all, we're actually enabling a whole lot of other permissions. We can see this by running Deno --help on the run command. And if we scroll up here, we can see that we're allowing a whole lot of other permissions when we do --allow all. We're allowing environmental access, which is what we want to do, but we're also allowing high resolution time. We're allowing network access to the entire internet. We're allowing loading plugins and file system access. We're even allowing running subprocesses. All of this for a simple hello program. Not ideal, right? Okay, so we've learned we shouldn't allow all permissions for every Deno program that we write. And we know it's better to be specific about the permissions that we allow. The good news is, there are some approaches we can take to make our life easier. I'll see you in the next one. Say we've done some development, and we're finally happy with the state of our Deno program, and we just want to make it easy to use. We could create a script, for example, in a Bash shell or PowerShell on Windows, and pass in the minimum amount of permissions needed to run that program, just like we do here. The only thing is, you'll probably need several different versions of these scripts for things like testing, running, and caching the program. And you might need another different set of scripts if you're part of a team that uses different operating systems with different shells or terminals. Deno provides a command to do this in Deno install. This will install a Deno program complete with all the permissions that it needs to execute. Once installed, you can access the program from anywhere in the path, the very same path we used when we were installing Deno. So we can do Deno install and then pass in our permissions --allow--env and the name of our program, main.ts. Exactly the same as if we were running Deno run, just with install here. And as we run this, we can see that Deno compiles our file and then installs it. We can now run deno-example anywhere in our terminal, just as if it were any other program, like VS Code. This is pretty great. Conveniently installing and distributing our programs is something Deno makes very easy for us. But why was our executable called deno-example? Well, if we do deno help install and scroll up, we can see that, first of all, we can change the executable name by passing in this flag, but also that the executable name is inferred by default. So Deno attempts to take the file name as the executable name, but if the file name or the file stem is something generic, like main, mod, index, or CLI, then it takes the file name of the parent path, which in this case is deno-example, the name of our folder. Okay, that's going to be really useful. But in a development environment where our code is constantly changing, we don't want to have to continually install and uninstall our programs. For development, we're going to have to use something like a task runner. We'll learn more in the next video. Welcome back. Something that'll come in useful as we build larger, more complex Deno programs that require more and more permissions and different configuration is a task runner. A task runner is a role that is filled by packages.json and npm in Node. One common example of a task runner that's not tied to any language is the GNU Make tool. This is a build automation tool that is most often used with languages like C and C++, although it can be used with any language. And it's used to create one file with a set of commands that we can run to do various different things that we need to do as part of our development process. Make has inspired a whole slew of different Make-like programs, including Ant, Rake, MS-Build, and many others. You might have heard of some of these. In fact, there's this entire derivatives page with a whole history around different versions of Make. Fortunately for us, Deno has its own variant of Make called Drake. If we go to the deno.land site and browse to our third-party modules page, we can do a search for Drake, and we can see that it is a Make-like task runner for Deno. And if we scroll down here, we can see that Drake files, or the files that define Drake tasks, are actually just TypeScript files that Deno can run. So let's try copying the example here into our example project. And we're going to create a file, drakefile.ts. We're going to import this sh function that Drake exports, and we're going to use it to run a shell script. And this will take care of running the commands that we send it to your shell, regardless of whether you're running on Linux, Windows, or Mac OS. So we're going to pass in exactly the same thing we did before. Deno run --allow env main.ts. And this is an asynchronous function, so we're going to call await when we call it. That requires the calling function to be async. Now we're going to run our Drake file by calling Deno run, and we're actually going to give Drake access to all of our permissions here. because Drake is actually running our commands here, which are already passing in the lowest amount of permissions we need. So Drake is only acting as sort of a messenger here. Our program is still run with only the permissions that we pass it in. And we're going to change this message here to say hello from Drake. All right, so back to running the program, we're going to pass in Drake file.ts. And then the name of the task that we want to execute. So in our case, hello. Let's see what happens. Deno is downloading the latest files from Drake, and check it out. We can see that our task started, and then we have this message from our Drake file, followed by hello Adam from our little Deno program, and Drake even tells us how long it took to execute our script. Very cool. Now, Drake is actually a lot more powerful than what you can see here. In fact, it provides a full API for scripting your tasks. In fact, Drake files are actually fully featured Deno TypeScript programs. So they can do anything your NPM scripts could do in Node and more. They can do anything that Deno does. Now, you should have a more complete understanding of the different options that you have for running your Deno programs with the correct permissions. And don't worry, in case you didn't understand anything from this Drake program, we'll be covering everything we did here in more detail throughout the course. See you in the next one.